So we'll be going through lambda functions, and this is a question from 2019 to 2020. Yeah, and I thought it would be nice to just go through a bunch of the particular type of question for CS 1030 final, which is one that's focused on lambda functions, which are higher order functions. And by doing like many of these, you get used to the process of how do you create a lambda function, how you examine them, and how you take in the inputs to the lambda function and get the outputs. So here's our first question. So here we have to predict the output of this lambda function. So here it is g lambda x 2 times x plus 1, and then we take the input as 3. So basically we are using this function, so we're passing in a function as the input f, which will take in another input x declared in this lambda function plus x plus 1 and this function which is f. Alright, so we can see that basically what will happen is when we call g, we are returning this line. And by the way, feel free to pause and work this out on your own before watching the solution, the rest of the solution. Yeah, back to it. So we're basically gonna be returning this, and notice that this x doesn't refer to this x. Alright, so they just want to confuse you, but technically we could use any letter here. We could also use y here, and it'll be the exact same answer. Okay, so we're going to return lambda x, where the function f is this function. So that is 2 times x plus 1. Sorry, lambda y. Yes, lambda y plus 2 times y plus 1. Y plus 1 plus 1. Then we wrap this in a 3. So we get 16. And that's it. Our next question we have this is from this year paper, 2021 to 2021 sem 1. So these are all actually real questions from past year papers, so just extracting them. So here, and yeah, feel free to pause and just like follow along whenever you want to, yeah, just follow along. So here we have lambda x y z, x y x z. So immediately we can see that x is a function because x is a function here, and it takes in 3 inputs in this lambda function. One is the function, and then 2 values after that. So here we are actually going to result in this lambda function x times 2. So this is the function x. Let me copy that, paste it here, where we input the first. So this is what it looks like broken down from this. So we should get, we put this 4 into this x, and we get 4 times 2, 8. 8 plus 10, right? Should get 18. Yeah, and the original one, oops, yeah, 18. Okay, so for the next question, with this. Okay, so something we need to be very careful about. When you want to create a list of functions, what we would expect, right, is something along these lines. If you look at this function, x plus, for I in range 0 to 10 with a step of 2, lambda x plus 2, lambda x plus 4, and so on, right? This is what we would expect. However, if you run this function, you will actually realize that this function is not scriptable. Oh, sorry, because it's not supposed to be that. It's supposed to be this. Okay, we'll get 15. What else, if you had a list of this, you would expect that at the third index, you have the lambda function x plus 6, right? However, and then we'll take lambda x plus 6 and pass in 7, and you get 13. But that's not what's going to happen. That's not what's happening, because basically what's happening here is that you have a bunch of lambda functions, but they all have the value of 8. So you can say 8 plus 6 is 14. 8 plus 3 is 11. So all of them contain this lambda function. And the reason why is the last value of I changed to 8 in this column when you iterate through. And so I became 8. And that's what all these lambda functions will point to. Yeah, it's a bit different because it binds, you can search it up. It binds the I to the actual variable variable value. Yeah, that's a bit complicated, but don't worry, it'll get simpler from here. All right. So next question. Okay. We have a map object. So immediately, okay, first thing, right, is you cannot, map objects can't be accessed like list. Map, filter, and reduce objects all cannot be accessed like, you can't just access it like this. You have to convert it to a list first, or a tuple, yeah, things like that. So what you get is error. It's not scriptable, subscriptable. However, for the purpose of this, so in the exam you would write that an error occurred. So the option is there will be an error. But for the purpose of this video, we will assume that this is a list version, and then we'll try and figure out its output. So its output is quite easy, right? So we're just looking for the second index. So you can see that you'll create a list, something like this. It's I for I in range 30. So we pass in 0 to 0 floor 3, floor division 3, and we will just get 0. Then we pass in 1, we'll get 1. And when we pass in 2, we get 2, and so on. So now, sorry, we don't get this. My bad. We get 0 up till the second index, and then we get 1. So, and so on. So if we print M, we get something like this. Yeah, because when you divide a number that's less than 3, it rounds down, so it's technically 1 divided by 3 is 0.333. But when you floor it, it grounds that value down, it rounds it down, so you get 0. So that's why we get 0 here, based on this list. Okay, next. Here we have this function, where it's this. And this function basically returns the, I think it's Unicode value of this character, of whatever character it is. So for example, it's 104, and these are all special values that are predetermined somewhere in a table, right? So the reason is you don't need to know what this it will actually output with odd. So you don't even need to know what odd A is, but you do need to know that odd B is 1 plus odd A. So since because A comes after B comes after A, so odd B will be 1 more than odd A, and same goes for odd C, 1 more than odd B. Odd C is 1 more than odd B. Okay, so when we sum, so we are mapping each digit in each character in this string to this function. So we run it in odd. So let's say first is C. So we will get a map function, map object, with 1 plus the odd of C minus the odd of A. Odd C minus odd of A. So what is the difference between C and A? Is basically just two steps. So we have 1 plus 2, right? Okay. Then we have A. We pass in A here. Odd A minus odd A plus 1. That is just 1. And then we put odd B minus odd A is 1 plus 1. So we have 2. So the sum of this map object, you can sum of it, will be 1 plus 2 plus 1 plus 2, that is 6. So we should get 6. Yeah. Okay. Moving on, we have this. So basically, here the question is asking what is true about the following function. So the question is, what is true about this function? And here are the options. And right off the bat, you can examine this to be true, to be correct, but I won't do it here. You can very easily see this though, and this is like a bonus mark for this question, because you don't even need to know that this is a lambda function. Actually, all you need to do is, you can see that if the list here is empty, you're going to be evaluating the minimum of this, and this is going to return an error, because the minimum of an empty list will return an error. Yep. So the answer will be this. It will crash if the input is an empty list. Next, we have questions from the special semester. Okay, so let's start here. These are quite simple. Just a refresher. Print this. So we can see that what happens, right, when we input 2 into this function as x, lambda x, it returns 3. Since there's no x involved in our return part, such as this, it's simply going to return 3. Right? Yeah. It's just as simple as that. If just because you declare an input x doesn't mean you're going to use it in your function. Right? Okay. Moving on. Alright, so we have this. And okay, so basically what we can do is, look, we have two parts. This is the input to this function. So this function lambda y is 1 is this input x, not this x. This is another variable, and actually we can change it and still get the same result. So let's do that. Let's try changing this, because this x, and this x are different x's. Okay, these are different x's. Okay, now let's break it down. We're going to put this function in here as x, this outer x. So what we get is lambda y 1. Let me put 3. Okay. Okay, then from here, what's just going to happen is, remember how, okay, so first we're going to take, so sorry, it's brackets here. First we're going to take this part. This part, remember how we tried to do this? And all it did was just return 3 because 2 wasn't involved, x wasn't involved in this operation that's returned. So likewise here, 3 is not going to be involved, y is not going to be involved in this return part here. So all of this is going to return 2, yeah, like that. And then we're going to pass 2 in here, but it's the exact same thing, we're just going to return 1. Right, so all this is just 1. And this will return 1, and this will return 1. As you can see, changing this did not make a difference, because these are 2 different x. If we change this, I think there'll be an error. Yeah, of course. Yeah. Okay. Now we're looking at this. Right. Okay. So we're gonna pass in this tuple, and there's 2 braces because this is the input, like the part where you input to the lambda function, and this is for the tuple. So this is the tuple, and you're passing it in here, and you're just summing it. Not much. I think it's just 5. Right? Just 5. Yeah. Okay. Next, print the list of a filter object. Remember the filter object. This is the condition, and if this function outputs true, then we keep whatever element it is that we are looking at. So basically what's happening is we're passing in each element of this, of whatever list this is, right? Whatever list this is, and if the element in that list, when we input it into this function, if that element causes this function to output true, then we keep it in our list, and we just keep it in our list. So if all those elements made our lambda function return true, then the filter would not filter them out. They will keep them like that. But obviously something's going to be filtered out. Okay, so let's see what. Or not actually. Okay, so here our function is going to return a string, and a non-empty string, a string which has something in it, is considered to be what in Python truthy and not falsy. So this is truthy. A string with something in it is truthy. So it acts like it's true. So if, let's say I did this, print hi there. Okay, we print that. But if it's empty, we don't print anything because it acts like a falsy value. Okay, same like 0. We don't print anything, but 1 causes it to print something to do with digital logic, and 1 and 0 representing true and false. Anyway, so this is actually true, and all this is going to evaluate to true for all of these elements, because none of these elements play a role in determining this. This is a string, and this x here has nothing to do with this x. Yeah. So the result we can expect, the whole list comes out like that. Right, okay. Next one. Here. Okay. Basically, we have to try and understand what's going on in this function. Def swap. We seem to be swapping the function order, because here we have fg, here we have gf. Right, so from a high standpoint, we can look down and see that the general perspective is just swapping the order of the function. That's what it's doing. But here, okay, let's look at the actual input. So we have two, a function, another function, and we are ultimately, after everything's done, we're going to put 10 into this result and print out the answer. Okay. So firstly, we're going to input 2 lambda x and lambda y into this function. Okay, we're returning this function. Okay, the way I think about it is, firstly, we have 2, right? And since n is 2, this is not 2, which is not true, because any integer besides 0 is going to be a truthy. So not true evaluates to false, and this is not going to evaluate yet. So we return this instead, lambda x, where we swap starting with 1, g, and f. So notice that we can, from the start, we fix f as lambda x function and g as the lambda y function. So here we swap it, and yep, okay. Now we have swap 1 gf, so we can go through the same motions again. It's not going to trigger this. We can return, here will be lambda x, but this is a different x. But that won't matter, because when you have this kind of format, everything's just going to telescope and collapse. Right, so we have this, but this time swap will be 0, and we swap them again, because when we pass it in, right, what was this before this? We had this before, where this is the lambda x, lambda y. So when we pass in lambda x, again, this becomes the f. Sorry, this is lambda y, it's lambda x. Right? So we have lambda x. Okay, so going back to the start, we have swap nfg, where f is lambda x, and g is lambda y. And then we return this thing. This is after the first step. We return lambda x, swap. Then we swap places, lambda y, lambda x. So now, when we go back into this function, lambda y is f and lambda x is g. Okay? So now let's remember that lambda y is f. So here, when we go here, since lambda y is f, after the second step, we have 0. And g is lambda x now. We have lambda x here. Lambda y. Okay, so now we have this. And now we're going again into swap. Because notice we have this here. Right. Okay, so now we have 0. And this is going to trigger. So we're just going to return lambda x. Is this. So we're going to return this whole thing. It's just going to return lambda x f. Always just our f. Let's write in the line. What's just our f? F is lambda x, our most recent one. So we have f on the outside, lambda x, and then lambda y on the inside. And then remember we take this 10 as our input. So there should be brackets around this. Yeah. So you're going to input 10 here, and that thing's going to do nothing because just like this is not involved. All these x's are not the same. They're not the same. So by putting 10 here, these are basically all 10s. Because when we call it, I didn't write it in. These are all 10s. But these are not all the same. This x is not referring to this x. So when we call 10 here into this part, it just vanishes like this. Then when we call 10 to this part, it also vanishes. This is all very informal, but that's the idea of it. Then we still call it one last time actually, because we should have 3. After this we had 2, and then we had 4 more. So we're going to have this red. So this is 10. So lambda y, 10 minus 1 is 9. And then we do the outer function. 9 times 9 is 81. So we should get 81. Yeah. Next question from final 2019-2020 Sem 1. These are all real questions. So what is the result of the following expression? Alright. Okay, so we have to see what's the result of this. And evidently, let's just take a moment to look at this. Evidently, we have this big lambda function. and then it returns the result of this small little lambda functions. Okay, so I think these x's are not this x, but this x is. So you can tell because you want to look for the x that corresponds to this outer lambda function. This is the only one that's not in any lambda function except for this. This one belongs to this lambda function, which is not the same x as this. Same goes with this. And these x's are not the same as this. So this is the x we're looking for. And we're going to pass 2 into this function. And it's going to come out as this x. So basically, if we rewrite it, it's going to be this. This whole thing translates to this, right? Okay, and then next step is sorry, there's brackets around this. Oh, there's no brackets, sorry. Okay, so that is what's happening. And then if you notice this, right, this basically does nothing. When we pass this into this function, all it is just going to return itself. So you just get this operation again, and then we pass 2. So the answer should be 2 plus 2, which is 4. There we go. More questions from the same paper, this paper. Right, so here we have a function called crack, and we are trying to figure out the output of this. I think it's, where is it? To figure out the output of crack. Here, these are the options. Although we shouldn't really rely on options and try and figure it out. If possible, we should just be able to figure it out from looking at it and be confident of our answers. Right, so we are going to pass in 8 and a function. So, this function returns itself. So the first conditional is if n modulo 5, if it's not 0, this will execute. So remember, 8 modulo 5 returns the remainder, which is 3. And we're going to return this. We're going to return crack n plus 1 and g, which is this function, which is this lambda function, compounded with this. So which is just basically lambda x, right? And then you're returning lambda x. And what this is going to do is it's just going to return itself, because you're going to pass in this x and input into this part. Let's say we're going to pass in an input 3. Let me just comment this out. We're going to pass in an input 3, and all this do is just going to return nothing but the next function. So should be, so this make a difference? No, it's just, yeah, sorry, you need two inputs. Yeah. So it's just gonna return the last input that you give it, because all the others don't matter. Okay, so right now we have we're passing in this, so we're passing in crack 9, and then basically the function that returns itself. We can simplify it to this, because it doesn't matter that we compound it, but for simplicity's sake, to analyze this function, it would be easier for us to just simplify like this. And then basically we're just going to continue doing this, if you notice, until n modulo 5, like some number k modulo 5, some number n modulo 5, sorry, becomes 0. And then if you see this conditional statement, right, it says if 0, that means, remember 0 is a falsy value. This is going to evaluate if false, and if statements only execute if this is true, this part here is true. So it's going to return once and for all just the function g of that value n that was passed in at that time. And you can see, right, as we increase n, it's going to eventually get to a multiple of 5. So we start with 8, 9, and then we're going to get to 10. 10 modulo 5 is going to get a 0 because it's totally divisible and there's no remainders. So at long last, we will return this function g of n, which is this function with 10, and the output should be just 10. Let's check. Yeah. Alright, so we have this. Sorry, I just had to check something real quick. It was raining. Yeah. So okay, so we're gonna check what the same thing. When does this return a truthy value which is not 0? So maybe we can go through the list elements one by one. 10 modulo 1. Yes, that works because 10 is fully divisible by 1. So we're going to eliminate 1 from the list, because if 10 modulo 1 is 0, this evaluates to 0, and that's a falsy. So we're going to only keep those things that make this true. Remember, we are filtering out things that make this false. And if 0 is false, we're going to kick 1. So the list does not have 1 anymore. Move on to 3. 10 is not divisible by 3, so we're going to keep it. 10 is divisible by 5, we're not going to keep 5. And 7. 10 modulo 7 is 3, so this is truthy because 3 is non-zero, and we're going to keep 7. So we should output 3, 7. Yep. Okay, moving on. There's a question about combinator, and I really like how they, I think they probably know about this thing called the Y combinator by, is it Stanford or Harvard? It's a startup accelerator. Yeah, so pretty interesting. Can look that up, where they have a good course on how to start a startup. I mean, a good video about that on YouTube that you can. Okay, so I'm gonna solve this, and okay, I brought in some extra help because I think we need to go through some things. It's a very tricky question right here. We need to talk about scope. So I just copied the function back down here. Let us consider the case where we declare a variable and we set combinator to be here. Right, let's look at what's going on here. We are going to input a function into this return statement, and basically that function, this is going to be this. Right, I know it's not this because this lambda y and this y has just been created, and it can't be, or it will be, I mean, it's possible to be the exact same, but it's not going to be for the purposes of our function. this y is going to be this y, right? So when we pass, when we can simplify this into, since this is a function that only depends on y as for the output and not on x, it's just basically going to be y, where y is this function that we pass into combinator, right? Okay. So what's going to happen is this y is going to go into this x and come out as this x. So y here is a function, and I could simplify this to lambda y, but it's going to be super confusing because this y and these two y's are not the same. This y was created together, but this y came from the input. So rather than do that, I could change it to x, where when I pass this y function, which is all this I'm highlighting is the same thing, into x, we can just call it x. And this new y is our auxiliary variables, like that's going to come out later after we establish this higher order function com. Okay, so basically we've simplified it to this. Okay, now before we move on, let's take a break and just think about what lambda functions do. If you can answer all these questions or have a good feeling of what they do, you'll be able to go back here, no problem. But let's take a detour, okay? Okay, let's have high, which is defined as lambda x, lambda y. And then we have lambda z inside there. Okay? So just think about this. What's going to happen? So we have high, 2, 3. But before that, let's just look at the inside. This y is this y. And what's happening is, let's look at this. I'm going to take the 2 first and put it up there. Okay. We're going to put 2 into this first, because there's lambda functions are, if I'm not mistaken, it's called left associative, which means we go to the left of the functions rather than right associative, which are things like power. So you would evaluate this as 3 to the 4 first, and then 7. It's basically this operation where it's right associative rather than left associative. So this is not correct. It's right associative, but here it's left associative. Okay, so we're going to pass in 2 there, and notice how that 2 just disappears, because none of this depends on this any x. I don't see x at all. So we're just going to make that disappear. Right? It'll just be this. And then we can pass in a 3. And I like to do this one by one. But technically you could have done it like 2, 3, and did pass the 2 in first, and then pass the 3 in. But let's do it one by one here. Okay, now we're going to pass 3 into lambda y. And it will come out as this 3 here. Right. So this will become 3. See? Maybe I should write down a different line. See how this becomes this. And now this is very simple to evaluate. It's just 30. So the output of this should be 30. Okay? If you got that, good job. So the lesson is the x in this has no effect. That's the lesson, because x does not show up here. Later on, deeper into the function, simply returns a function of y here. And this is something we're going to see very similar to the function combinator. So that's why I want you to get familiar with these concepts before we tackle that. Okay, next, let's see what happens here. We have a function def test y, which is mimicking combinator, which returns this function. So let's declare test t equals to instance of test, and we're going to pass in lambda x plus 1 into y, which would be this. Okay, and notice how x does not have any play on y whatsoever. Okay, so t is basically return, see this t, we can express t more fully as this, okay, we replace y with this function with y, and notice that this x is not at all same as this x. We redeclare x, and this x is going to look at this x, not this x. So right, if you notice, we want to get this t, we're going to pass in a, that is going to give us, watch, we're going to pass in a here. Right, this is what's happening. We want to print this. So let's see what happens. We pass in a into this x, but this is not going to show up anywhere else down here because these x's are not this. We redeclared it in a new lambda function, and I could rewrite it technically as y here, and it will give me the same thing. So this should give me a lambda function. Yeah. Okay. So when we print this, this is going to give a lambda function. Now, what happens if we add another input 2 here? Because this is basically what's happening, right? This is test. This is this part. These two are the same. So we know that a has no effect, and it destroys, just takes out this part. It like soaks it up for the real juicy part where we get this evaluation, which is 3. So likewise, this should be 3. Okay, moving on. Let's look at this now. Notice how it's the same thing, but we can change this z to z, and comparing here, it will be the exact same thing. Because notice that this is a much more visual way to see this, where we have this same x, but they're really not the same, right? So this should also output 3, because this 2 has no effect. Let me write it out fully. In the same way, t is lambda x plus 1. No, sorry, we return this, right? Lambda z y, where this y is being passed into test as lambda x plus 1. I hope this is all clear, and I may stumble a bit, but ultimately, if you are able to follow along with my own corrections or whatnot, that's really good. So this is what's happening. When we pass in 2, t2, right, the first 2, well, let's do it concurrently. What's happening? When we pass in this first 2, right, left associativity, remember? Pass in this 2, we destroy this z because z doesn't show up anywhere else. It's just absorbed, right? This 2 is absorbed. And then we can get to this. So this first one doesn't matter, only the second one. Alright? Okay, so that should output 3. Yeah. Okay, moving on. T is this function. Just trying to build intuition here, right? Okay. Let's see what happens here. If we write t out fully, we have this. Okay, and we can start to destroy things. Remember that this x is not this x. This x. This x comes from this function. And if Python were to like confuse itself and make all these x's refer to the same thing, that's just like weird. Because you don't want this x to somehow be related to this x, right? So it's somehow redefining it in the second lambda function, because when you use the same letter, just to make everything work correctly, Python has to redefine what x is pointing to inside here. It's not referring to this anymore. On the other hand, if I put an x, for example, here, for whatever reason, I don't think this is going to work, but for whatever reason I have an x here, yes, this x refers to this x, because it's not being redeclared in another lambda function. Okay? For whatever reason that occurred. Okay, so we can start to absorb. 2 goes in here. Pass in as x, right? But it disappears because it's not the same as this x and it doesn't show up anywhere else. So we can get to the meat and potatoes, which is going to result in 3. Okay, we're getting there. Okay, so for this example, notice how this is different, because if I write it out, we're going to actually use the y. When we call, look at this, we have lambda x plus 1. Now we have lambda x plus 1 plus y. We're now going to actually use y, okay? Because it's a different letter from x. These are not the same thing anymore. But we're actually going to use it. Contrast, okay, wait, let's just do that. Okay, so we pass in 2 into this y. And since y does show up, and it's not redeclared in some other lambda y here is directly connected to this y. It's not being redeclared. So what we get is lambda x plus 1 plus 2. Because when we pass 2 in here to here, it goes all the way to here. Right? And we're left with this outside 2 here. And then we can evaluate this based on x, which is 2 plus 1 plus 2, which is 5. So this should be 5. Okay. Now let's contrast that with let's put an x here. What's going to happen? And let's change this to x. What's going to happen? Okay, without making another cell, we're going to pass 2 in here into t. It's going to get absorbed by this. But notice that we don't have anything other x's outside this lambda function that's inside. And this one, inside, redeclares x. So both these x's refer to this x, not this one. So what we're going to get in the end is that this 2 here is absorbed by this. Nothing happens. And we're left with this. So we're just left with 2. Where this 2 is this outer 2. Okay, so the answer should be 5. Okay. Now, let's look at this. T is lambda y. Okay. Lambda x. Right, same thing. Let's pass in 2 here. This y. Notice how this is what? Not dependent on y at all. 2 is just going to be absorbed. And we are just left with this 3 to feed into this part. If you can't visualize it, just write it down in your exam. Just do it. No shame. So, cut this, absorb it into this lambda y. And then we are left with this. So it should result in 30. Yeah, okay. Now, let's go back to the original function. Wow, that was a long way away. And what I did here was basically just changed this part in the function from y to z. Because notice that originally it was like this, right? Where we have y here and then y here. I know this y is related to this y because you can't just declare this standalone lambda function without first having a reference, and this must be the reference. On the other hand, this one is referring to this y, which is suddenly just only instantiated, sorry, not redefined, instantiated. So this y and this y, okay, slight apologies. That was I have a correction to make, just a small correction. Okay, everything I said was mostly true. Okay, let's go through it again, and I'll tell you where there's something important. Right. Okay, so we're gonna evaluate this, and basically we're gonna have this, right? We're gonna pass in this. So all this, okay, we have this, sorry, we have all this. This y is this function, okay, where we can replace this y with this. Notice that this x is not this x. So we can't just destroy it, okay? Sorry, my bad. We can't just destroy it in this case. Cases where you can, let's say x, right? Lambda y. Here you can destroy the x because it doesn't matter. Here you should keep it, okay? And where you can change it to another name because x doesn't matter. Just to be clear, this is what's happening. So we're going to pass this into x in here. And what we'll get is lambda z, this thing, pass in with z. Okay, so watch how this becomes this. Now, we're going to pass 11 in to here. What's going to happen is 11 is going to pass in as z. Okay, 11 is going to be passed in as z. There's parentheses here. And we're going to get this, correct? Watch this, how it's become this. And notice this, because we renamed our x to k, this 11 is just going to be passed in here and absorbed as nothing. So watch how that 11 is nothing. And after we call the second part, we're just going to call 12. So this should be 120. You follow? Similar to just what we went through just now. We can have like a dummy variable here that just simply absorbs your first input, leaving the way for the second input to do all the juicy stuff. Alright. Yep. Sorry if that was a bit confusing. Hopefully get the gist of it though. Expound on that because I don't think that was clear enough. The reason why we couldn't, like, let's say we took this and I passed in what lambda x is x 10, right? And I couldn't just like shorten that into this is because I might have inputs later that I need to absorb. So if I had done this, the 11 would have worked because there was nothing to like cushion it, right? You're basically dropping these inputs into this, and the 11 was cushioned by this part, and it wasn't used in the function. So if I had just taken away this, the 11 would have been evaluated, and instead we would have gotten 110. So let's say I didn't leave it in, which is the correct thing to do, and I put 11, 12. What's going to happen here is 120. That's correct. But if I just say that, oh, since it's returning itself, or some weird stuff like that, which actually makes sense in your head but doesn't actually translate. Just because you have lambda x here and lambda x here doesn't mean it's just magically going to like telescope, like contract into each other. You have to leave it there. If not, this is going to happen. It's not correct because what you're doing is passing 11 in here, and you're going to get out of this 110, right? And then you're left with this, which doesn't make sense. So you need that cushion behind there. Yeah, hope that was clear. So you need that whole cushion to be passed in to the rest of your function here. Alright? Yeah. So the next few questions are actually from a paper that I already made a video on, 21, 22, Sem 1. But I thought I would take a few of the lambda functions and put them here in this video and redo them, just for my sake, so that I don't get complacent, I guess, so that I actually know what's going on. It's always good to review, and so that this video is just complete. Alright, so here we have a function f which is a higher order function, takes in two variables and then one. So we see that corresponds here, where we take two functions and then two functions, right, which correspond to this x and y. So if we want to write this out fully, basically this is what's happening, and I think it's better this way. Even though it's really long, as long as you keep track of your parentheses and where everything's going, everything should be fine. Okay, so firstly we left associativity, right? So we put this in lambda xy, and what we get is, let's copy that. What we get is these two functions are put in x and y, come out here. Okay, so let's keep track of what's happening. We take this first, put this here. We take, okay, we can delete that. Then we take this, put this here. Then we delete that. Okay, that was confusing, but you can see the how we get from here to here, right? Is should be quite easy to see because these are all different things. there's one whole thing here, 2, 3, and 4 things. And we took this and plopped it in this part. Okay, so we got this. Now, wow, this is one whole big thing. Now let's put this 3 in here. Okay, let's put that 3 in there. Okay, notice how this whole thing, which z are we going to, which z does this refer to? So it's referring to this z, not this z, because like we saw before, this z refers to this z, which has been redeclared inside this its own little lambda world. These are all dummy variables, so Python isn't like causing this z to suddenly refer to this z. It's referring to its own thing. It's just called the same thing. It's just on the outside it looks like a z. This z, on the other hand, is referring to this z, which when we put 3 into this function, it's going to be 3. Now let's evaluate this inside part first. Okay, so we put this 3 in here as the x, and we can see that this x is the same as this x. It's under this lambda function, this part, this lambda function here. Okay, let's do that. We put the 3 inside there. Alright, let's go back, cut. Okay, resume. Yeah, so we go back, we put this, if we put this 3 in here, right? Let's take out that 3, plop it in here. Y is just going to return 3, which is, yeah, so it's going to be this. And basically what's happening is, wait a minute, it's correct. Sorry, we're not taking this 3. We are, the thing next to this is this lambda z function. My bad. Okay, so we're gonna put this lambda function in the x. Sorry, sometimes I really can't see either. And note that this lambda x is this x. So what we're going to get is this lambda function here. Okay, can you see that how we got from here? We put this in here, and it, since this lambda y returns just x, which is the same as this, we get this. Pause the video a bit. It's a bit weird. Okay, now we pass in 3 as y. But since y is not in this lambda function, y doesn't show up anywhere. It's just absorbed. Just like that. Similar to our previous examples. And then finally we get just 4 times 2. Right, these brackets don't mean anything. We're just going to get 4 times 2. So this should be 4 times 2. 8. Yep. Okay, next one. Wow, that looks hairy. Harry, you're a wizard. Okay, so we have this, where f3, let's write out everything. Okay, let's write out everything. f3 is this. That's f3. And we're going to go right associative. Left associative, my bad. cxy. This corresponds to these three functions. We pass it to this, okay? Where f1 f2, f3. So c looks to be like a function that wraps around x and y, where x and y are they themselves f1 and f2 and f3s. They themselves are functions. So we can get further into this mess by writing that out more fully. f1, f2, f3, right? This representation, we output this, and then we have f2, f1, 1, 0. We don't need to care about this part so much, so we're just going to plop it to the side. We just need to evaluate this part. Sorry, I didn't mean to run it. Okay, we have this and this. So we have lambda xy return x. So f1 is this, and we can play this game of just like, you know, we have this variable, let me just like substitute the whole thing for that. Just remember to put the brackets around so we know what we're dealing with. So that, right? Alright, can we follow that? f1, we just replace with f1. Okay. Now we have this. So we have this function which takes two inputs and only returns the first one. So basically this whole thing is just f2, right? Can you see that? We put f2, f3, we're just going to return f2. So we have f2. Okay. And then f2, what's f2? It's this function. So we replace f2 in brackets with this. And now can you see what's happening? We're going to take two functions, and this time we're going to turn the second function, which is f1. We're going to take this whole thing, becomes f1. So we pass in 1, 0. f1, we're back here. f1 is this. I just replace this with f1's definition, and it returns the first thing, so we should get 1. Here we go. That was hairy, but nice. Okay, so here we have some more questions. These ones are from 2022-2023 Sem 1. Okay, so let's get to it. f1 is this function, takes 3 inputs for f2, and then we are trying to evaluate what's going on here. Okay, so f2 is, let's write out everything. f2, let's just take this, plop it in these brackets, and then plop f1 4, 7 outside. So it takes in 3 inputs, right? Which is correct. That's what we see here. Where a is the function around 2 other inputs. So we're going to take f1 now. And this is the format of a, b, c, right? As we see inside. So we get this. I'm going to get this. This is a. And this is b, c. So we're putting this inside here, and we're going to get this format out. ABC, which is A, and then BC, right? It's all just like pattern matching. You just mix and match where you see the formats are. So you know this is a function that matches. So we know on the right track. And all we do is just add them together, right? So we should get 11. Yeah, that wasn't so hard. Okay. So now we are looking at this. We want to know, that's a really... Okay, let's do this step by step. So get a filter. Filter this. Okay, what is this? f is this, so we're going to put f in here, right? And range 0 to 10 is just 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we want to keep things that we're going to filter out things that make this falsy, right? Remember? So pause now if you can do this yourself and you get to the answer. Okay, when we make this falsy, this has to be 0. We're going to filter out things that make this 0, and we're going to make this 0 when this thing is divisible by 4. So what are numbers that are divisible by 4? Well, 4 is one thing, 8 is another. So we're going to keep basically the whole list except for 4 and 8. So this is our list after we filter it. And then, since this is actually a filter object, we need to make it into a list. So this is the list, yeah. We're going to count the len of it and print that len. So what's the length of this? I'm just going to comment this out. It's 8, so I think we should get 8. 7. Where did I go wrong here? Oh. Okay, so my bad. 0 is also when you print 0, 1 to 4, you also get 0. So 0 is also going to be filtered out. And yeah, we should get 7, sorry. Okay, so here we have this. Notice we have a map object, which we need to make it to a list, which is what happens. So we map this. Okay, and the first thing we want to think about is this going to work? This is not a list, this is a string. So I think I haven't done this question, but I'm going to guess that we can do that. We're going to take each digit or object of this iterable string, and it's going to be a list anyway, but we're going to multiply it by 3, but it's not going to be multiplying the digit. So what we're going to get is, first, we're going to put the string 1 times 3, and what we're going to get is 1, 1, 1. Okay, I don't know whether this is going to work, but we can learn together. And basically this is just going to be what's happening. We put each string digit in here. It's a string, so we multiply it by a number, it gets a string, but a bigger string. So okay, this is what should happen. What could happen? Oh, okay, yes. Alright. Okay, so when you see these kind of things, don't straight away think to yourself like, oh, it's a string. It's only meant to have lists, you know. What if it's meant to have iterables in general, all kinds of iterables? So in that case, it could work. And then what you do is you store them in a list after that. So this part is not exclusive to lists, although after this operation you do store them in a list. Like the result of this on each element of this iterable, you store it in a list, so it does give you a list after that. But the input is not dependent, doesn't have to be a list. Okay, so yeah, great. CS1010S papers. And if you haven't seen what a CS1010S paper looks like, basically, I think they changed their programming language from Python, but I'm not sure. Are they still doing Python? I think they're doing C now. Yeah, I think they're doing C. But back in the day, they were doing in Python. So you can. It is helpful to just go through a bit of past papers for them. Maybe this will be more accurate. Stuff like blockchain, interesting applications, Scrabble tiles. This looks really interesting. just fun programming assignments to do in your free time. Anyway, I just took the lambda stuff from like here, the part A, multiple choice questions. Yeah, let's get to it. So we have CS 10 papers. Okay. What we can do, I haven't done this myself actually, so bear with me. We're doing it together. Right, so we're gonna print this, and first thing I do is extract the thing we're looking at, and then work backwards from there, right? What's gonna happen is we have G2. Okay, what is G? G is this function where we return this lambda function which has x on the outside. So it takes in another function and applies it to its own input. Okay, so we copy that and just copy the format. Right, that would look like this, where we put 2 inside this thing. So we're going to absorb it, right? Just like we've always been doing as x, as wait. Okay, wait. Interesting. G2, yeah, as sorry, as y, because G2 we're outputting. Sorry, we're just doing this. Okay. So forget what I said. We are returning this where this is 2. G2 is this thing. The rest of it is this. But this is G2. Because we pass in 2 as the y, and then we return lambda x, returning x as a function of 2. Okay. Now, left associativity. We're going to get f thrown into this function as x, and it'll be given an input of 2. So what's f to this function? So we can absorb f into this. Okay, so always remember to look at the step before and look at the step after to see how we transition from one to the other, right? Okay, so currently this is one thing and this is another thing. Let's look at what we just did first. We just blindly copied and pasted these function definitions into each other, and we need to really think about what's going on. So I don't know if you can hear the rain. It's raining outside, but okay. Anyway, let's try and evaluate this first. We're going to pass in interesting. What are these x's referring to? See, if we just blindly apply these things, we don't know where did these x's even come from, right? So I don't think we could just do that. We should, instead of going here, right, let's go back. Let's go here. And when we pass in f, excuse me, when we pass in f, what we're going to get is, from here, right, we're going to get f2. And from here, that's where it starts to make sense, because f, we pass in 2 as this x over here. That's what those x's were referring to. So now we can finally replace f2 with this, where those x's are 2's. So notice how I'm just like kind of like doing it systematically in parts, so that I don't get mixed up with like this x and this x and this x, this x, this x. So it's quite easy to do it this way. Okay, so now we're going to pass this in to this y. Right? So what we're going to get is quite simple. Just going to replace the y with lambda, that lambda function. There we go. So notice we have a tuple. This is a tuple, right? And you can evaluate this side of the tuple. That would just be 3, right? So we should get 2, 3. Yep. Quite easy, quite easy. Okay, this one. Let's extract what we're looking for. Okay, f. What is f? You notice that we have an f here. F takes an input fun, and don't mistake this for this input. It's this function. So they like to confuse you by using like a lot of words. In actual fact, we could technically replace these two with some dummy variables, but we won't, because that's not in the spirit of this game where they're trying to trick you, right? So we'll let them trick us. We'll let them try and trick us. This f, we are going to return. We're going to print fun. Okay, and the aim of CS1010S is also to match the exactly what happens in the output. So you have to match also your like print statements. Whenever they print, you have to follow it. So let's get us our own inputs, output space, and write down whatever happens. Okay, so we meet this print fun later. Okay, we're just going to do it now. Fun. And we're going to transform this f, right, into this. So notice how f, this whole thing represents the fun in f. And now we're just like matching stuff, right? We're just pattern matching. We look at this. Oh, it looks like this. So therefore, like inside is fun. So we can say that, you know, the fun here is this inside. And what happens here is we return fun2. So we can take that inside. We take the inside only, and we call fun2. Fun2. Now that's interesting, because there's also a fun here. Which fun are we exactly referring to? Let me think. Because I think since we called this one, and we have this here, it's closer to this when everything was compiled than this function. So we're going. I think fun2 refers to this one. Wait, I don't think we're going to call this. So what's happening here is we are going to just call this normally and see what happens. We're not going to call fun2 on this, you know, and then okay. So now we just have this. This is all we have. Just start over. We have this. Okay. Now, I think there's a bracket here. Yeah. So you've got to be careful with your brackets. It doesn't make sense to not have brackets. And we called fun because it was this whole thing, so we should always put parentheses around it. Okay, now we put 2 inside there, right, and absorb it, and that x becomes a 2. So watch how it transition. Okay, and this time we're really calling this function 2. Okay, because when we instantiated this here outside Python, like the way Python compiles is it reads everything first, and then it assigns everything kind of its scopes from the start. So here, when it compile stage and run stage are 2 different things. Compile stage, it looked at this thing and it said it points to this, not this, because this is the closest to this. And in compile stage, it looked at this and pointed it to this, because this one only it's local to this function, right? The scope is just not the same as this. These two, these are the same. Right, so this time we are definitely, since these two are the same, referring to this function up here rather than this input variable. So we're going to call this now. We're going to print f, and we're going to return this f lambda x plus 2. Very interesting. This x is not showing up at all. F lambda x plus 2. Okay, so it looks like this x is not actually being used, because note that we have this redefined x. Even though they are called the same thing, they are not. And I think we went through that throughout this whole video, like a lot. So basically, fun2, we're going to return this. That's just simply what we're just going to return. We're just going to return this, ignore whatever happened, ignore the fact that we have 2 here. It's just not going to be, it's just irrelevant, right? So we just have this. So now we go back to f, and f says that we print fun again, and we return fun2, where fun is this input. So we take this, and put 2, I think, yeah, and we get 4. I think we get 4. I think this is what we get. This output. Yes. Okay. Nice. All right. Here we have this function. Sorry. Okay. Print once. Okay, so we should have an output space again to track what we're actually outputting, and then we just have our workspace. Okay. This looks painful. Let's get this, because this is once what we want, right? And then later we can call 8 onto it. But we leave out the 8 for now, for simplicity's sake. So we have twice. So twice. Okay, let's call twice. We're going to call twice with twice. We're going to print yes. Okay. Anyway, we're going to return lambda x. We're going to return this, where t is x. T is twice. Okay? So we're going to return this, where t is twice. So we call t twice. Alright. So this is our very messy but necessary long statements. Okay. Now we have these two big components. Oh wait, we can resolve this first. Okay, so let's copy this, paste it here. Let's resolve this part. We're going to put 2 in as lambda y. So this resolves to this thing. Resolves to this. Okay? That's why parentheses are important, because this whole thing is just one thing, separate from the rest. So we can evaluate it first, using this 2 as this y and this y. Right? Okay. So now we have this. Now we can put this as this x and absorb it, and then what we'll get is absorb it, That's the way I like to think about it, at least. Is this right? So this is what we get. Then what's twice? Twice is so we do the inner part. Twice of this. Can do. So we're inputting t, and we're calling twice. So let's put yes. Where t is this lambda function. So we're going to return. Let's copy this. We're going to return this. Where, if you remember correctly, after we replace this, t is lambda x plus 2. Same goes here. Lambda x plus 2. Remember, it's okay to just slow it down, pause the video if you're having trouble. Okay. Okay. What's happening here? Wow, that looks absolutely painful. Okay, I think we can check this. What's going on here first before we go on? What is going on here? So if we pass in let's say we pass in some random number like 2 into this whole thing, what's going to happen is 2 jumps in here. Whoa, what is going on? Okay, I think that's supposed to be... Okay, wait, let's go back. I think we start back from here. We need to use parentheses, because if not, everything is going to go bad. Okay, twice is this. We're going to replace those t's with this inside lambda function. We're going to keep those parentheses. This is t, this is t. Alright, we need to keep parentheses. That is very, very important. As I can see here, this whole thing is this whole thing, right? We just ran the twice on this inside part. Okay. Now, I can see that we can do this part first. Let's do this part first, because it's its own separate thing here. This part, we can change it. Okay, remember we need to do twice one more time, but we are doing this inside part first. This is the inside part. Okay, we can change this to just be, right, input an x here. What do I get? Oh my goodness. Okay, this is so weird, because that x is, that is weird, right? That's weird. Okay, I think I know what's happening. I think I know what's happening. Let's say we put a variable outside. This x is going to be 3, because this is one whole thing, and this lambda function is one whole thing, but this x is outside. So if we pass 3 in there, you get this, okay, to be 3. So this inside part, let's say it's 3, right? We can reduce it to just be 3. And then from there, what we have is 3 plus 2, 5. And then this input is passed as, this output is passed as the input to this, where we add another 2. So basically all of this is just adding 2s, right? Okay, so from here I think we don't need to go on. We can guess the solution. Assuming an arbitrary input x, this will just be adding 2 with the multiplied by the number of times that you call this lambda function. So we compound it, right? So in total, we should get 8 as x, this big x. And then 8 is going to add on 2 by the number of times. So notice here that for this inside part, we multiply it twice by 2. This outside part is going to do that again. So in the end, we're going to have basically 2 of those. Alright, why don't I just, okay, why don't we just do that, work it out once and for all. Okay, this x, big X, is going to be this final variable that we pass in. This, okay, what we have here is after this inside call, right? Okay, so what we get is x plus 2. We can cut this down to x plus 2, where x is our final variable call. And then what we get here, this simplifies to, if you put x plus 2 as this input, you're going to just get x plus 4. Okay, and then this one is the result of calling this with this input, where we call 8 as an arbitrary x. And we do the same thing. We put this back inside here, but this time the x is x plus 4. We do it again outside. We just finished this and got this, where with an expression in terms of an arbitrary value x, where x is our input to this function. We can do it again, and what you'll find is, I think what you'll find is, sorry, this is the x. What you'll find is that you add up, you get x plus 8 in the end, which is 16. So technically we called, how many times did we call twice? We called twice, yes, and then we called it 2 more times, I think 2 more times. And then we finally output 16, right? I think that's, okay, I don't know, something like that, yeah. So that's the gist of it. I think I missed the yes. Accidentally added a yes. Oh, because we called this once only. Yeah. Okay. Close. That will earn us about 4 marks in the CS Standard S paper. Okay, moving on. Here we have this is our what we want. And what's bar? Bar takes in 2 functions. That's what we have here, and spits out this. So let's replace bar with this, right? And left associativity. Okay, wait. Too fast. What is going on? Okay, bar is this. Sorry, my bad. bar is this. So we have this, and then we're going to put those as the place of f and g. So that's f, this is g. Okay, finally, okay, nice. And then we put f5 outside all of this, because all of that is this. Okay, then what's going on is we can okay, this x refers to this x. We pass in this whole thing into x. Okay, so we can simplify this. We can pass this whole thing, absorb it as this x. Whoa, that's a lot of parentheses, and delete that. Okay, so notice how we got this thing in there. This is kind of just like, you can forget about that. We know that this whole thing is one thing. No matter what, I don't know how many parentheses I have, but it's one thing. Okay, and I'm going to pass in 5 as y, but the functions don't depend on y anymore. That is interesting. They don't depend on y. So can we just take this out? Just the 5, right? Okay, I think the 5, where is it? Okay, so bar this. I mean, just, oh, it's not what I thought. Okay, cut. Oh my, we have a lot left. Okay, so we have this function. Start again. This function. And we want this, right? Let's take this out. So bar this is going to be this, where f is, what is f? F is this function. And g is this function. All called with 5. Right. Alright. That was exhausting. But we're not done yet. Notice how this does not depend on y, so in a way, whatever gets passed here isn't going to matter. That's interesting. Okay, so this whole thing is 1. What x is that referring to? Oh, I destroyed. Okay, so I think we can, this whole thing is 1. Alright, we can pass this 5 in now because we just have 2 things. Okay, let's absorb it. Wow, that was straining my eyes like crazy. And this x is going to be 5 because it's the only x that's not redefined. Oh, besides this is also going to be 5. See, this x is outside this redefined x lambda function. Same goes with this. This x refers to this and also to this. So we get this. Okay? And now we have two different things. We pass in y. Okay, wait, let's evaluate this first. This gives us 6. Just plain old 6. This gives us 10. So, okay, very interesting. I think the answer is 6. Yes. Because this has no effect on the return value. Y has no effect. When we pass in 10, it has no effect on 6. Alright, wow, that was, let's recap. So we passed in bar, these two functions. Then we got this very heavy expression where it was so important for us to have the correct parentheses. And then we could pass in 5 because this whole thing is one thing. And we had to insert 5 where the scope made sense, which is this and this. And simplifying, we get this, and we separately evaluate those because we those are within parentheses, and we get this. Yeah, so feel free to just digest. Okay, moving on. Almost there. We have 4 more. Then I think this video will be over. Okay, let's hope I can quickly get through this. Okay. Looking at this. What's F? Okay, we need an output space. Output space. Output. Make sure the video is saved. Okay, here's our output space. F is here. Okay, so F is this function. So we can replace F with, no wait, we have to separate it. F1 is this X. We're going to print X, so we print 1. And then we return lambda y, gy, plus 1. Okay, so this is F of 1. And then call 2 and 3 after that. So notice how this transforms to this. The first line transforms to this. Okay. Then this gy refers to this. Cause that was how it at compile time Python decided it would be. When he read this, it looked for a gy. It couldn't find a gy anywhere, so it had to be this. Okay. So now we're gonna call gy plus 1 where y is 2. So gy plus 1 where y is 2. And then outside is 3. Okay, so what is G2? G2 is lambda y, y plus 2. Okay, lambda y, y plus 2. That's G2. Okay, plus 1. And then we call 3 outside. Okay. We're also going to print x. X at this time is 2. Okay. G2 plus 1. Okay. I think now we can pass in 3. So we get 3 plus 2 plus 1, it's 6. Okay, I'm going to run. Oh, okay, so sometimes, yeah, I didn't see this coming. Looks like you can't add a function to a number. So actually in the CS1010 as paper, you will not be able to you'll be given the option that uh, you might have to answer that it gives an error. So yeah, determine the printer output and write the exit output and state if there is an error message and why. So that those kind of traps exist. I'm also myself not very familiar with that, but let's move on. Okay, let's get the result of this. What's foo -1? We return foo -1. We return this lambda x baz x. Okay, so foo -1 is just simply this, where x is -1. Interesting. Foo -1 returns lambda x. Wait, so does -1 have no influence on the function? Because it just returns that, right? Well, the scopes. So this x is referring to this x. This x is referring to this x. And okay, so we gotta keep track of everything. This x is this x. Okay. Interesting. Okay, I think I got it. Let's just remember that this part refers to this, and so this will be -1. Okay, just keep that in mind. Moving on, we have this, right? So we're going to put 0 in there, and we're going to call baz 0. Okay, what is baz 0? Baz 0 is going to return this, where y here we replace with 0, and remember this x is -1. Okay, so we have this. And then we call 1 after that. So this became this. Rewind the video, or I hope if it's correct. Rewind it and hopefully it's correct. You'll be able to see what's going on. Okay, so we pass in 1 here, and yes, I think we're going to get the answer. We're going to get this v1. v1. Answer 0. Yes. There we go. That wasn't too hard, right? Okay, we got to look at scope. I think scope is really important, because if not, you're going to get mixed up with this x equal to this x, or this x is what x, you know. Okay. Oh, another twice thing. Okay, so we're looking at once, 1. And what's once? Twice, twice, well, 2. Twice, twice, well, 2. Okay. So after that we call 1, right? After this whole thing. That's what's happening. So firstly we can maybe look at output space, because we're going to be printing stuff. Okay. We have this little thing here, wow2, where we print 2 and we return m plus n plus m. Okay. This thing we can replace with this, where n is 2. It's 2 plus n, right? Okay. Now let's look at this. It's not a higher order function, it's an actual function. Where we have this. So print yes once, I guess. Or maybe it's the other way around. So we return lambda x. We return this where those are twice. Oh goodness gracious, this is going to get hairy. Okay, twice. Wow. Twice. Okay, so then we pass this in, right? Into this x. So we can reduce that to twice x. Where each twice. Oh my goodness. Is a lambda function. Whoa. Okay. Oh my goodness. So there's brackets because this one is after that, all this stuff. And I think the same thing goes, you know, like I think this one is going to be passed in and it's just going to be added. It's going to be added a lot of times. Lambda. Sorry, this is not what's happening. This is, we are passing in this, right? So it becomes twice, then we put that in there. Okay, this is correct, I think. Okay, then we do twice. What is twice? Twice is this. So you can see what is happening. It's going to be twice and twice of that. So we have 2. We're going to get like 2 out of that. 2 functions of this lambda function, and then we're going to times 2 again. So we're going to have 4 in total. We're going to do 2 yeses because 2 twice, right? And we're going to put 1 in there, and we're going to add to 1 4 times of 2. So it looks like this, right? 4 times 2. I think the answer is 9. Yes. Okay, but the orders were wrong, because I think at the beginning I should have followed the order of from left to right. So we call twice first, and then we simplify the other part. So we call twice first, it will output yes first. Okay, last one. I think I'll go back to that. Okay, I'll go back in more in depth. I think I really haven't done this before, so I'm really happy that that worked out. But let's try and work through this exactly, like what's going on. So firstly, we had ones, right? Ones, 1. So this is ones. We returned twice, while 2. So twice, while 2 was, we determined was this, where the 2 became the n. So we had this, right? Correct? Just try and pause and ponder about it. Then we had to evaluate this part. Twice of twice. That's, I think it's safe to say, twice of twice, you're going to return this. T, 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 T. I think that's what's happening. And then you have this. So when you pass this function in here, right? Sorry. When you pass this function in here, you get like this compounding effect. And since this is a linear function, all you do is you just add to whatever m is a lot. So on the outside we have 1. And what's going to happen is this 2 is constant, right? This m is the only thing that's unchanging, and each time you get an output, it becomes the input for the next outside function. It becomes the input for this, and the output of this becomes the input for this function, which becomes the input for this function. And you start with 1. So that tells me that you start with 1 as this m, you get 3, and then 3 becomes the output, which becomes the input for the next one. 3 plus 2, 5. 5 plus 2, 7. Then 7 plus 2, you get 9. So that's how I kind of think about it. I'm really scared of writing it out fully because I think it's going to be really messy, but I hope you get the gist of it. So here we have this, and what we want is what's bar, right? So we're passing in bar, passing this. This is what we can translate everything to. This is what's happening. We go from this step to this step. This is what's happening. So we can pass this in as x, and this is the same x. So we can simplify this further to this, where there are still brackets around here. Okay. Then looking at this, we can take in foo. If this is one whole big thing, the next thing is foo, and associatively put it in. Associatively, I don't know if that's a word. Foo is going to replace all these y's. So it looks something like this. Foo of foo. And then you get this. Okay. And then what's going to happen is you evaluate foo of foo, which is, what's foo? Foo is this function. So we can replace this foo with this. Yeah, so notice how we go from here to here to here. So you look at these two lines. Now I can take my foo and put it in here and get more foos out of it. And I think this is an infinite loop. Am I wrong? This looks like a loop. Yeah, it's a loop. It's a loop. It's a loop. Okay. So in the 1010 paper, right? They will ask you to write whether it's a loop or error or what, and I'm just going to write it's a loop, and that's correct. That's full marks. Then we have to give a reason why. It's because we're just going to keep calling foo on itself. See, like this x is just going to call itself again, like how we called this. Yeah, so I think we're done.